Hi you guys, I am ready for lesson 3 of module 13. So go get your math books and a pencil and follow along with me. So lesson 3 is called represent and name fractions of a whole. So yesterday we learned about unit fractions, and unit fractions describe one equal part of an entire group or whole. So now we're going to move beyond that and name any kind of fraction. All right, so our I can statement says, I can use a fraction to name an equal part of a whole or an equal part of a group. The Spark Your Learning says, Miranda draws a circular design for a playground game. She colors 1 part yellow and 3 parts blue. All of the parts are the same size. What fraction of her game circle is blue? So this is a story problem. The first question I asked myself is, what do I need to find? I need to find what fraction of her game circle is blue. The next question I asked myself is, what information am I going to use? I'm going to use that it's a circular design. 1 part is yellow and 3 parts are blue. Okay, so it says show the fraction of Miranda's game circle that is blue. So I'm gonna draw my circle as best I can. It looks like a potato. And then I'm going to, I should use a pencil. I keep saying that, but so then I'm going to divide this into equal parts. Now to do that, I need to know how many parts in total I have. Well, 1 part will be yellow plus 3 parts that are blue. That gives me 4 equal parts. So I'm going to divide my circle into 4 equal parts. I'll kind of go like that. There we go. All right, so 1 part is yellow, so I'm gonna do Y for yellow. 3 parts are blue, so I'll do B for blue. Now I'm going to write the fraction of Miranda's game circle that is blue. Well, I know that fractions, on the bottom number is my denominator, and that tells me how many pieces of the whole there are, and I have 1, 2, 3, 4, so that number goes on the bottom, and then the number on top is the number that I'm counting. So what am I counting? I'm focusing on the blue, so that's what I'm gonna count. 1, 2, 3 blue parts. So my fraction will be 3/4, 3 over 4. The Turn and Talk says, what fraction of Miranda's game circle is not blue? How do you know? Well, the fraction that is not blue is the yellow. There's 1 yellow piece, so that is going to be 1 over 4. Still 4 on the bottom because my total didn't change. What changed was what I'm counting. So instead of focusing on the blue parts, now I'm focusing on what's not blue. All right, next page, page 362. Build understanding. Number 1, May draws a hopscotch game that has 6 equal parts. She uses pink chalk to number the first 2 squares and green chalk to number the rest of the squares. What fraction of the squares have pink numbers? This is a story problem. The first question I asked myself, what do I need to find? I need to find what fraction of the squares have pink numbers. The information I'm going to use is that I have 6 equal parts. That's my total. Maybe I draw an arrow and I label that total. She uses pink chalk to number the first 2 squares, so the first 2 are pink and the rest are green. Do I know how many green squares I have? Not yet, but I can figure it out knowing that I have 6 equal squares total and the first 2 are pink. So the first instruction says show May's hopscotch game. So I'm going to draw this rectangle and I'm going to divide it into 6 equal parts. So I'm going to draw 5 lines. 1, 2, 3, 4, 5. Again, you kind of have to eyeball it and just do your best judgment. So 1, 2, 3, 4, 5, 6 equal parts. The first 2 squares are pink, so I'm going to write P for pink. And then the rest are green, so I'll just write G for the rest of them. All right, how many equal parts are in the whole is what part A says. There are 6 equal parts. How many equal parts are being counted? What am I focusing on? What am I counting? I'm counting the pink numbers. So, how many pink numbers do I have? 2. 2 parts. What fraction represents the squares with the pink numbers? The squares with the pink numbers go on top because that's what I'm counting. And then my total number of squares goes on the bottom, 6. Okay, so over here we'll connect to vocabulary. It says the numerator tells how many parts are being counted. The numerator is the number that goes on top, tells us what we're focusing on, tells us what we're counting. The denominator tells how many equal parts are in the whole or in the whole group. So the denominator, again, is the bottom number, and it tells us how many parts are in the whole group. Number 2, for this hopscotch game, the green squares represent what fraction of the whole? Write the fraction. So we're still using May's hopscotch drawing. How many green squares? It says, what is the denominator of the fraction? That is the same as before, 6, because the total didn't change. What is the numerator of the fraction? So this number is going to be different because instead of counting pink squares, now I'm counting green squares. How many green squares are there? 1, 2, 3, 4. So the fraction will be 4 on top, 6 on the bottom. 4 sixths. All right, number 3. Tommy is playing 6 green marbles. To win the game, Tommy must capture all 6 green marbles. Complete the fractions to show each round of the game. So here we have round 1. How many green marbles are shown? Well, my total is 6 marbles. 1, 2, 3, 4, 5, 6. How many are green? 1. So my fraction is 1/6. For the round 2, my number of marbles has stayed the same, 6. How many green marbles are there? 1, 2. Kind of an interesting game. Round 3, there are still 6 marbles, so I'm going to write 6 on the bottom. How many green marbles? 1, 2, 3 green marbles. And after round 4, I still have 1, 2, 3, 4, 5, 6 marbles. So that goes on the bottom. How many of them are green? 4. Part B says, if the pattern continues, what fraction of the 6 green marbles will Tommy have after round 6? What fraction does this represent? Explain. So this is round 1, she had 1 green marble. Round 2, she had 2 green marbles. Round 3, she has 3 green marbles. And round 4, she has 4 green marbles. So at round 6, how many green marbles do you think she would have? 6. So it would be 6 out of 6. What fraction does this represent? Well, 6 over 6, that represents all the marbles. So that's what I would write down, all the marbles. All right, okay, let's do the check understanding. The red sections represent what fraction of the playground spinner? Write the fraction in words and numbers. So how many pieces do I have in my whole? Well, I have 1, 2, 3, 4, 5, 6. There are 6 different sections on this playground toy. So 6 goes on the bottom. How many parts are red? 1, 2. So I have 2 over 6 as my fraction. In words, I would write 2 as the number 2, so TWO, 2 sixths. Lots of sixths. Okay, next page on my own. Number 2, look for repeated reasoning. Julie colors 4 spinners. Complete the fractions to name the part of each spinner that is red. So the first one is done for us. There are 4 sections, 4 equal sections on our spinner. One of the sections is red, so our fraction would be 1/4. This one, it looks like 2 of the parts are red, so it would be 2/4. This one, 1, 2, 3 sections are red, so there are 3/4. And finally, 1, 2, 3, 4 sections are red. The whole thing is red. So 4 over 4 means that the whole thing is red. Describe a pattern in the fractions for the spinners. So what is happening every single time we move to the next spinner? Well, you could say that we are adding 1 part of the spinner that is red every time. So we call that our unit fraction, right? Our unit fraction is 1/4. We are adding 1/4 every single time. There's 1/4, and we're adding that 1/4. So now I have 2/4. Here's my 2/4, and now I'm adding 1/4 right there. So now I have 3/4. So you would describe, you are adding a unit fraction every time. And the unit fraction is 1/4. All right, number 3, write the fraction that names each equal part. Then write a fraction to name the shaded part of the whole. Okay, so each equal part, I am talking about my unit fraction. So every time I say each equal part is, I want to think automatically unit fraction. My unit fraction, I wrote it down underneath, unit fraction is 1. That kind of looks like a fraction. I didn't mean for it to look like a fraction with like the line and the top and the bottom. I did not mean for that to be a fraction. So anyways, the unit fraction is 1 piece. So 1, 2, 3, 4, 5, 6, 7, 8 equal parts, which means each piece is worth 1/8. Does that make sense? Then write a fraction to name the shaded part. So how many pieces or how many equal parts are shaded? 1, 2, 3, 4, 5. 5/8 is shaded. Now number 4 says shade 4 of the equal parts. Write the fraction in words and numbers. So I'm going to shade 4 parts. 1, 2, 3, 4. Now I have 4 parts shaded out of how many equal parts in my whole? 1, 2, 3, 4, 5, 6. So I have 4, F-O-U-R, sixth. S-I-X-T-H-S. Then 6 goes on the bottom because that's how many equal parts I have in all, and 4 of them are shaded, so that goes on top. All right, number 5, music. Each space between the lines on this musical scale identifies a musical note. You guys probably know all of these because of music theory and violin. The 4 basic notes are shown, F, A, C, and E. Circle each A note. What fraction of the notes on the scale are A notes? So here I have my musical scale. So F, A, C, E, faces in the spaces. I have this note is an A and this note is an A. I'm just following along that space. So what fraction of the notes on the scale are A notes? Well, 2 of them are A notes. How many notes do I have all together? I'll count 1, 2, 3, 4, 5, 6, 7, 8. So 2/8 of the notes are A notes. And you would explain how we got that. Well, we just circled all the notes along that A space, and then we just counted up the total number of music notes in that whole scale. And that's how we got 8 on the bottom. All right. Okay, are we feeling okay? We kind of breezed through that whole lesson. That was pretty quick. So I hope that this is making sense. I hope that you guys are following along okay. Remember, we are building the foundation for learning about fractions. So this may seem really easy, but we gotta nail it so that when it gets a little more tricky, we have this foundation to come back to. So keep working hard, keep doing your calendar math every morning and doing your homework, checking your homework. Junior, are you gonna come say hi? Say hi, can you see him? Come here. Hi guys, hi. He's saying good job doing math. All right, love your guts, see you later.